Hello friends, no, I'm back with another topic. So today let's discuss about the traveling salesman problem using branch and bound technique. Actually, this traveling salesman problem is referred to as a zombie topic. It's a very funny thing. It has many approaches to solve this traveling salesman problem. It can be solved using backtracking and Hoffman's principle and these branching and bounding technique. So today let's see one of the methods solving traveling salesman problem using branch and bound technique. Now, branch and bound approach. Now it's nothing but let's discuss about with the example first. There is a salesman. He has to start from his home and see the sales in each and every city, and he should return back to his home. That's it. That's the problem. And what we have to find now, to complete his journey, the minimum path, the total minimum shortest possible route to complete his tour. We have to find this one in this traveling salesman problem. Okay. What we are given is we will be given a graph. Will be given a weighted graph. Now let's see what will be given, like a set of cities in the sense nodes. You will be given set of nodes and distance between every pair of cities, like edges. You will be given nodes and edges of distance means you will be given weighted edge. So you will be given a graph with the nodes and weighted edges. You have to find the shortest possible route to complete the tour of the salesman. So let's discuss the rules of traveling salesman problem. These are like constraints. So first rule is every city has to be visited exactly once. Like each and every city should be visited, and each and every city should be visited only once, not twice or thrice. Only once you have to visit each and every city. He has to come back to the same city where he started the journey. Of course, he has to return to the home after his journey. Like he has to come back to the same city where he started the journey. That's the second rule. And the third rule is we have to find the shortest possible route to complete his tour. There are many routes possible in the given graph, but we have to find the shortest possible route. Now let's see this simple example. I'll just discuss the example here. Let's see the process and how to solve this in the next example. See, there are four cities are given, A, B, C, D, four nodes, and these edges means distance between each and every city. Let us suppose he started his journey from city A. From city A, he has to visit each and every city, and he has to return to his starting point, that is city A. So now the path applying this traveling salesman problem algorithm using branch and bound, you will get a path A to B, B to D, D to C, C to A. This is the shortest possible path to complete his total tour covering shortest distance. One of my friends asked, we are using Digstar's algorithm, right? So why we need to use traveling salesman problem again? Yeah, that's correct. We'll use Digstar's algorithm to find the shortest possible route from the starting vertex. If from A to you need to visit C. Okay, Digstar's algorithm gives you the shortest possible route to visit from the selected vertex to all other the vertices. So we can use that approach also, but that's a greedy approach. Now what we are using is branch and bound approach. So this is a slight difference between these two. And see, A to B and B to D and D to C, C to A. This is the path he will be taking to cover the minimum distance and complete his tour. So the cost will be calculated A to B 10 and B to D 25 and D to C 30 and C to A 15. So sum of all is 80. So he need to cover 80 units to complete his total journey. So this is simple example. Now let's see the approach, how traveling salesman problem will be solved. First step is reduce the initial cost matrix. Like you have to reduce the rows and you have to reduce the columns. Let's discuss this in the example. And find the cost of each node. Select the node with the minimum cost. Okay. Now let's discuss each and every step in this using this example. So I hope this example is clear for you. Oh, yeah, it's clear. See, Given in the given example, they given the set of nodes A, B, C, D. Like these are 4 cities. Assume that these are 4 cities, and they given the directed edges between 2 cities. Like A to C, the distance is 12. Not this is 12 is not the distance from C to A. It's A to C. C to A distance is 11. So they have given a directed weighted graph. We have to calculate the shortest possible route to complete his journey. Okay. So first and foremost thing, if they have given graph, you have to draw the cost matrix. Cost matrix in the sense like adjacency matrix. All the nodes A, B, C, D and A, B, C, D. There are no cycles, right? So A to A will be infinity, B to B will be infinity, C to C will be infinity, D to D will be infinity. Now A to B, the edge is 4. Okay. A to C, the edge is 12. A to D, the edge weight is 7. Okay, 7. So like this you have to fill each and every row and column. This is the initial cost matrix. Now we got the cost matrix. Now the second step is we have to in the first step itself we have to reduce this cost matrix. Reduce in the sense we have to reduce row wise and column wise both. First we will reduce the row wise. Row wise reduction means this is the first row, right? Find the minimum element. Minimum element in the first row is 4. Okay. And the minimum element in row 2 is 5. Minimum element in row 3 is 6. Minimum element in row D is 2. Okay. You have to subtract each and every row with its minimum element. Like in the first row minimum element is 4, right? You have to subtract infinity with 4, 4 with 4, 12 with 4 and 7 with 4. You have to subtract like this. And then the matrix is said to be reduced row wise. Now let's reduce this. Yeah, it's clear, right? I hope it's clear. Yeah, see, infinity minus 4, infinity will give infinity. 4 minus 4 will give you 0. Okay, and 12 minus 4 will give you 8. 7 minus 4 you will get 3, and 5 minus 5 you will get 0. Infinity minus 5, infinity minus 5, infinity. 18 minus 5 you will get 13. Okay. Okay, and in the third row minimum element is 6. So you have to subtract with the 6. 11 minus 6 gives you 5. Infinity minus 6 gives infinity. 6 minus 6 0. Okay. 10 minus 2 8. 2 minus 2 0. 3 minus 2 1. Infinity minus 3. Infinity minus 2 infinity. So like this you have to reduce row wise. Now let's reduce a column wise. A column wise in the sense you have to select minimum element from the in the column. In this column minimum element is 0, so need not to be reduced. In this column minimum number is 0, so need not to be reduced. And in this column minimum element is 1, so you have to subtract each element of each and every element in the column with 1, and minimum element in this column is 0, so you need not to be reduced. So only reduction you have to perform is in this third column. You have to subtract it with 1. See here, 8 minus 1 7, infinity minus 1 infinity, infinity minus 1 infinity, 1 minus 1 0. Rest of the columns remain same since the minimum element is 0. Okay, now this is the reduced cost matrix. You have achieved reduced cost matrix. Now let us assume this as 1. Okay, this numbering will be useful in the further steps, so I have giving numbering. So now let's calculate the cost. Cost equals to sum of all reduction elements. Sum of all elements you used for your reduction. Like in the row reduction, what are the elements you have used? 4, 5 and 6 and 2. Okay, so you will be summing all the reduction elements 4 plus 5 plus 6 plus 2, and in the column reduction you have used only one element, that is 1. Okay, plus 1. So this will give you cost as 18. So let's draw this state space tree for this. So assume that we are starting journey from the node A. Okay, node A. So let's draw state space tree for node A. We have got cost as 18, and the matrix reduced cost matrix is 1. Like we have given number 1 here, right? Reduced cost matrix we have given number 1. Cost of the node is 18. Okay. Now from the state space tree, what are the remaining nodes to be visited? B, C and D. Okay. Now B, from here you have to visit B, or you have to visit C, or you have to visit D. Okay. Now you have to calculate costs for all these nodes B, C and D. Then you have to select the minimum. Okay. See here we are using branch and bound technique, right? It's a LCBB, like least cost branch and bound. Okay. Cost branch and bound. So we have to find the cost of each and every element, and we have to choose the minimum cost node. Okay. Now let's go to step 2. Let it be clear. Okay. Now step 2, you have to choose any one path, and you have to find the cost A to B, A to C, A to D. Okay. In the first step you are choosing A to B. Okay. Path A to B. Now A row and B column should be replaced with the infinity, and you are reaching node B from A, so you can't go back, right? So B to A should be replaced with infinity. So see the base matrix what we are having in the A. For A we have reduced cost matrix is 1, like you have given number 1, right? So just a minute. So this is row matrix 1, like this is the least cost, this is a reduced cost matrix, should be used for path A to B. Okay. Okay, this is the path. So what are the conditions? You have to replace A row with infinity, and B column with infinity, and B comma A element with infinity. Like you have to replace A row with infinity, and B row with infinity, and B comma A with infinity. Like this element should be replaced with infinity. So the same thing has been done here. See, let me compare so that you will understand it easily. Okay, see, A row should be 0 infinity, right? A row is infinity, and B column should be infinity. B column should be infinity, and B comma A element B comma A should be infinity. Okay, this is infinity. The rest all the elements have been written as it is. Okay, clear? Okay. Now we have to reduce this cost matrix. See, row, you have all the infinities, no need to reduce. In this row minimum element is 13. Okay. In this row minimum element is 0, so no need to reduce. In this row minimum element is 0, no need to reduce. So only row you have to reduce is second row. You have to subtract the whole second row with element 13. Infinity minus 13, infinity. Infinity minus 13, infinity. Infinity minus 13, infinity. 13 minus 13, 0. Okay. The rest of the rows remains same. We have achieved row reduction. Now you have to see column reduction. In this column minimum element is 5. In this column minimum element it's all are infinity, so no need to reduce, we can neglect. In this column minimum element is 0, so no need to reduce. In this column minimum element is 0, so no need to reduce. So the only column you have to reduce is first column. So subtract the first column elements with 5. Infinity minus 5, infinity. Infinity minus 5, infinity. 5 minus 5, infinity. 5 minus 5, 0, and 8 minus 5, you will get 3. The rest of the columns remain same. Okay. Fine. So we have achieved row reduction and column reduction of this cost matrix. Now let us number this reduced cost matrix as 2. Okay. Now let's find cost. So remember this formula. Just a minute. Remember this formula. Cost is equals to cost of parent plus sum of reduction elements plus m of a comma b. M of a comma b should be taken from the base matrix. Like now you are calculating a cost for node B, like path A to B. So the base matrix is 1. Clear? So 1, a comma b in 1, a comma b. Okay, what is it? 0. So a comma b is 0. Cost of parent node of this b is 18. Cost of this parent node of this b is a. Cost of a is 18. So cost of parent is 18 plus sum of reduction element. 13 is used for row reduction and 5 is used for column reduction. So 13 plus 5 plus 18 plus 0. M of a comma b is 0. Since we'll be seeing here a comma b, okay, it's 0. Okay, so we'll be finding the cost of b. Cost of b is 36. So replace it with in the state space tree. Cost of b is 36 and the numbering which you have given for reduced cost matrix is 2. Okay, fine. Now let's calculate for this part a to c. Choosing path from a to c. Repeat the same steps. Replace a row with infinity and c column with infinity, and replace c comma a with infinity. Okay, fine. Replace a row with infinity, c column with infinity, c comma a with infinity. A row, okay, this row, whole row should be replaced with infinity. That. Next, c column, this whole column should be replaced with infinity. It's already replaced. And c comma a should be infinity. C comma a, c comma a. This is replaced with infinity. Okay, fine. Okay, then now we have to reduce this initial cost matrix. See, in this row infinity, so no need to reduce, neglect. In this row minimum element is 0, no need to reduce. Minimum element is 0, no need to reduce. Minimum element is 0, no need to reduce. And in this column minimum element is 0, no need to reduce. In this column minimum element is 0, no need to reduce. Infinities we can neglect. And in this column minimum element is 0, so we no need to reduce. So the initial cost matrix is already reduced. So let's number it with Roman 3. Okay, now let's find cost of node C. Cost, the same thing what I have done. Cost of node C is equals to cost of parent. Cost of parent is 18. Cost of parent is 18 plus sum of reducing element. It's already reduced, right? We haven't reduced anything, so it will be 0. And we have taken A to C, right? So we have to see A comma C, A comma C, 7. Okay, 18 plus 0 plus 7. Okay, the cost is 25. So the cost of C is 25 and the number given for cost matrix is 3. Fine. Okay, now the same thing will be repeated for path A to D, and the cost of D is to find out. So let's skip this step. Okay, now see, cost of D is we got as 26 and the name given to the reduced cost matrix is 4. Okay, the reduced cost matrix is 4 and the cost of D is 20, node D is 26. Okay, fine. Now let's take the minimum element from these 36, 25 and 26. The minimum element is 25, right? So we will be choosing this path A to C. Now we will be extrapolating this node C. There are only 4 nodes A, B, C, D. Already A is visited, C is visited. The remaining nodes are B and D. So we will be visiting B and node D. The cost of the parent is 25 and the initial cost matrix is number 3. Number 3 in the sense we have taken A to C, right? Okay, we have chosen path A to C, right? The reduced cost matrix in the path A to C. So this is number 3. This is taken as base matrix for the further calculations. So now what we have to calculate the cost of node B and cost of node C. Path is A to C, C to B, and another path is A to C, C to D. We have to calculate these two and calculate path of cost of B and cost of node D. Okay, now this is the step 3. Okay, vertices B and D are to be visited from C. The same thing which we have got from the diagram. Vertices B and D are to be visited from the node C. Okay, don't confuse with the term vertices and nodes, both are same. And the cost matrix at C is the row matrix which is represented with the Roman 3. Okay, this is the initial base cost matrix we have to use for the entire step 3. Okay, cost of the parent cost of the node C is 25. Okay, remember these two terms. Now let's calculate for A to for cost of for B, A to C, C to B. This is the path, right? Okay, A to C, C to B. Now we have to find the element C comma B, because we will be using this to find out cost. So C comma B. In 3 we have to see, right? 3. Okay. C comma B. It's infinity. Okay. Fine. C comma B equals to infinity. Next, we are calculating for C to B. Since A to C is already visited, now you are visiting B from C. Okay. C to B. So C row should be infinity and B column should be made as infinity. Same as the previous step. C row and B column should be made as infinity, and this is a small change. So you are visiting A to C and C to B. So you can't go to A from the B. So B comma A should be written, replaced with infinity. Okay, that's the same thing I have written here. Replace B comma A with infinity. Okay. The base matrix is this matrix, right? Let's see this. Just a minute. Sorry. So you have to replace 0 and you have to replace 0 and D column, 0 and B column with infinity. Okay, 0 is this one. Okay, 0 is this one. You have to replace the entire column with 0 with infinity, and B column is second column, this column. You have to replace the entire column with infinities. That's what happened. And what you have to replace, B comma A with infinity. B comma A in the sense this one, B comma A. B comma A should be replaced with infinity. So it's done. It's done here. Okay, fine. Okay, now we have to reduce this cost matrix. First row all are infinities, so no need to reduce. And the second row, the least element is 13. So we have to subtract this whole row with 13. Infinity minus infinity, infinity minus 13, infinity, infinity minus 13, infinity, infinity. 13 minus 13 is 0. Okay, and in the third row it's all are infinity, so no need to reduce. And in the fourth row the least element is 8. Okay, so you have to subtract each and every element from of the row with 8. 8 minus 8, 0. Infinity minus 8, infinity. Infinity minus 8, infinity. Infinity minus 8, infinity. Okay. So now you have to reduce columns. Okay. The minimum element is 0. So no need to reduce. There is no minimum element, all are infinities. So we can neglect this column. And this column all are infinities. So we can neglect this. This column, the minimum element is 0. So you can no need to reduce, it's already reduced. Okay, so it's column reduction also done. It is reduced cost matrix. So let's number it with 5. Now let's calculate cost of B. The same thing which I have done previously. Okay, cost of B. Okay, cost of B is equals to cost of the parent node is C. Cost of C is 25 plus 25 plus reduction elements. For row reduction you have used 2 elements, 13 and 8, and column reductions you have used nothing, all are zeros. So 13 plus 8 plus we have seen this, right? M of A comma B, B comma C, C comma B, that is infinity. So summing all this, since it is infinity, the answer will also be infinity. So cost of B is infinite. Cost of B is infinite, and the cost matrix used is 4. Okay, now let's find out cost of D using this path, A to C, C to D. Okay, A to C, C to D. Same, we have to find cost of C to D. 0 D column, cost is 0. Now we have to C to D, right? We are visiting. Replace row C with 0 and replace row C with infinity and row D with infinity. Row C and column D, column D with infinity, and you can't go back to A, right, from D. So D to A should be infinity. M of D comma A should be infinity. So let's compare these two, you will get more clarity. Just a minute, sorry. Yeah, this one. So what you have to do, replace row C and column D with infinity. Row C is this one, okay, column D is this one. You have to replace both with infinity. Row C infinity and column D is replaced with infinity, and D comma A, D comma A is element, this element should be replaced with infinity, okay, infinity. Oh. So we have to reduce this cost matrix. First row is all are infinity, so no need to reduce. Second row is minimum element is 0, no need to reduce. All are infinities, we can neglect. Minimum element is 0, so no need to reduce. Columns, minimum element is 0, no need to reduce. Minimum element is 0, no need to reduce. All are infinities, we can neglect. All are infinities in this column, so no, we can neglect. So row reduction and column reductions are done. We have made no changes, so it's already in the reduced form. So this is the reduced cost matrix. Let's give this number as 7, sorry, 6. So now let's calculate the cost of D from the state space tree. Okay, D is this, right? Cost of D is equals to cost of parent node is C. Cost of C is 25 plus cost of sum of reducing elements. We have used no reducing elements, right? It's already in the reduced form, so we have to replace it with 0 plus the first thing which we have find, M of C comma D. We are going from C to D, right? So C comma D equals to 0. So 25 plus 0 plus 0, that equals to 25. So now you have got the cost of B as 25, D as 25, and the matrix used is 6. Okay. Now the minimum from these two, it is 25, right? So you have to select this path, and you have to extrapolate this. A is visited, C is visited, D is visited, the last one is B. You have to visit B. So now you have to find the cost of node B. A to C, C to D, D to B. Choose this path. See, you have to replace, you are visiting D to B, right? Now you have to replace row D with infinity and column B with infinity, and you can't go back to A, right? You can't go back to A, so B comma A equals to infinity, and you have to find D comma B, because you will be using in finding this cost. So D comma B, it's 0. Okay, D comma B equals to 0. Now resultant cost matrix after replacing all this, replacing row D means this one. You have to replace all the row D with infinity, and column B is this one. You have to replace all the column B with infinity. Fine. Okay, then now B comma element B comma A should be replaced with infinity. B comma A element is this. This has been reduced. This has been replaced as infinity. So this is the cost matrix. Now reduce this. We have to reduce this cost matrix. Since each and everything is infinity, we no need to reduce. We can neglect. This cost matrix is reduced cost matrix. Now let's find the cost from the state space tree. We have to find the cost of node B, right? So the cost of the what is the parent of this node B? It's the parent is D. So the cost of D is 25. Okay, 25 plus sum of reducing elements. We haven't reduced anything, so it's a 0 plus the first thing which we have seen, M of D comma B. You are going from D to B, right? So you have to calculate D comma B. D comma B equals to 0. 25 plus 0 plus 0, that is, you will be getting 25. So the cost of B is also 25. So the path you have to taken to complete the tour in the minimum cost is this one. We have seen the rules, right? You have to return to the same city where you have started. So the path is A to C, C to D, D to B, B to A. So we will be calculating the cost. A to C cost is 12, C to D cost is 6, D to B cost is 2, and B to A cost is 5. cost in the sense I am saying about weights of the edges. You, so it will be 25 units. So we have used the traveling salesman problem to complete this whole tour in the 25 units. So now let's see manually once this one A to C, like I'll use pen, A to C, like he is going in this way. Okay, A to C and C to D in this way, C to D. From D, he is visiting B, and from B he is revisiting to A. Okay, so the red mark I have included is the path followed by the traveling salesman to complete his journey in the shortest possible route. So this is about traveling salesman problem. It's a bit confusing. You be very thorough with this. How the base matrix should be taken, then you will be very clear. You will be very clear. So for the it's done level by level, right? Okay, it's done level by level. Okay, for the second level, you have to consider the base matrix of the first level. Okay, for calculating B, C, D cost, you have to use the base matrix of A, and for the third level, you have to use the base matrix of this C. You have to, for calculating costs of B and D, you have to take the base matrix as 3, which is mentioned as 3, base matrix of C, reduced cost matrix of C, and at the last level you have to take the reduced cost matrix of D. Okay, and this is about traveling salesman problem. There are many approaches for solving this, like backtracking and branching and bound, Hoffman rules, and many other things. For now we have seen branch and bound techniques, and you have any further queries, comment down below, and I am very much interested, and I am welcome to take all your feedbacks in the comment section. Please like, and if you have any queries, or else if you have any doubts, or you have any suggestions for me, please comment down. I am very glad to receive all this. Thank you guys. Thank you.